Look at how ocean water moves around the world. We're going to look at ocean currents. There are more than 20 major ocean currents which move large amounts of water semi predictably around the oceans. Um, Currents not only move lots of water, but they move lots of minerals, lots of energy, oxygen, carbon dioxide, plankton, and fish, which is why they're so important and why we're going to spend some time looking at them. Currents are caused and driven by water density and salt content, the wind, spin of the earth, coastlines, and the moon. We're going to look at each of those in greater detail shortly. The world's largest current is the Antarctic Circumpolar Current, which is by the Southern Ocean, and it's roughly 24,000 kilometers long. Right, there's no land down there to get in the way. So ocean currents can be divided into two different groups: surface currents, which are 0 to 200 meters deep, and the deep water currents, which are deeper than 200 meters. So, what makes surface currents move? One of the big drivers is wind. So, as air is warmed by solar energy, right, the sun, it rises and cooler air rushes in to replace it. This creates wind. As wind passes along the surface of the water, it pushes the water molecules and moves them along in the same direction. Uh, the spin of the Earth also has an effect. The Earth spins from west to east. You may have heard of the Coriolis effect. It causes deflection of winds and currents to the right or to the east in the northern hemisphere where we are, and it's the opposite in the southern hemisphere. And the shape of the continents, right? Currents move through the ocean and they have to move around the edges of the continents like rocks in a stream, right? They have to follow the edge of the continent. So that will affect where and how that current goes. Now, when we look at deep ocean currents, right, they're not going to be affected by factors above the water, right? There's just they're too deep for that. Um, but what does change is water temperature. So we have when water warms up, it expands and it'll rise. Cool water will fall to take its place, and we get somewhat of a density current where we have cool, dense water moving on the ocean floor. We have three distinct layers that depend on temperature. The surface, 0 to 200, that's warmest, right? Uh, Sunlight penetrates a certain amount yet and warms it up. Um, the second section there from 200 meters to 1,000 meters, we have the thermocline, we have rapid cooling occurring, and we have a distinct change in temperature happening. And below 1 kilometer, we have what we call deep water. This water is mostly the same temperature. It's just above freezing, right around 4 degrees or so. Um, Water salinity also helps create deep currents. When we add fresh water, right, when rivers are pouring into the ocean, we see a decrease in salinity. Uh, Evaporation and freezing increases salinity, right? If water evaporates or freezes, it leaves the salt behind. That's why we see some of the densest water at the poles, right? We have a lot of freezing taking place. So we have a lot of salt coming out of uh, the water that freezes and being dissolved by the water underneath. So it's very salty, very dense. We see upwelling occurring when nutrient rich cold water finally moves up to the surface for whatever reason. Um, this is really useful because it brings those nutrients up and to where they can be used. Ocean waves will affect the shape of the land. Most waves, especially waves that we see, are created by the wind. In the open ocean, waves are called swells. When they get to shallow water, they will break. We get that characteristic curl that we see, and if they're big enough, you can go surfing if that's your thing. The largest of the waves are called tsunamis. These are caused by either undersea earthquakes or undersea landslides or volcanic eruptions. So these are really large waves that travel really quickly and cause all sorts of devastation when they hit land. Now, waves are really good at eroding coastal areas, uh, depending on what those coastal areas are made up of. If it's really soft rock like limestone, it's very easily eroded. We get headlands, which are made up of harder rock. They are less erodible, and they absorb most of the wave's force, so they don't wear away, whereas some of the softer rock around them might. Um, Bays will occur between headlands. They're generally calm areas because all the waves are hit the headlands, lose their energy, and the space behind them is very chill. Sea stacks are extra hard rock left over from eroded headlands. Um, so some rock is really erosion resistant, so it ends up just standing there almost like a pillar. Um, Tides, we have high and low tide. They're caused by the gravities of the Earth and the Moon, and to a lesser extent the Sun. High tide occurs when the Moon is closest to the Earth. So over here, we're going to have high tide because the Moon is right there, right? The Moon has a certain amount of pull, and it pulls the water to it slightly. So the areas away from the Moon are going to have low tide, and the area opposite will also have high tide. The tidal range, that's the difference between high tide and low tide. This changes all over the world. In BC, it's about 3 meters. The Bay of Fundy in Nova Scotia is well known for having a very vast tidal range. It's one of the biggest in the world. Um, as I said before, the sun's gravity will also have an effect. When it's lined up properly, it can produce extreme tides. These are called spring tides. So these are kind of like super high tides. Um, when the sun, moon, and earth are not perfectly lined up, these are called neap tides. So these are more the regular or the not so super high tides.